In this next problem, we're going to find equations of the tangent line and the normal line at the point 2, negative pi for this curve cosine of xy equals 1 plus sine of y. I wanted to start by describing what the normal line is because we haven't really talked about this yet. If we think of a differentiable function, y equals f of x, and we're looking here at the point a, f of a, we know that our tangent, we can build our tangent line, which has slope f prime of a. This is our tangent line. And it goes through the point a, f of a. The normal means perpendicular here. The normal line is perpendicular to our tangent line. If we have a pair of perpendicular lines, their slopes always multiply to give you -1. So the slope of this is going to be -1 divided by f prime of a. Okay, but we build this in the same way as we built a tangent line. So once we know what the slope should be, we're going to use that y minus y1 is equal to our slope, in this case, -1 over f prime of a times x minus x1. In our case, x1 is a, and y1 is f of a. Okay, so this is our basic picture of what we're going to be asked to do. Now let's try carrying this out. Okay, so we have this curve cosine of xy equals 1 plus sine of y. We're going to differentiate both sides. So when we go to differentiate cosine of xy, we are going to be using the chain rule. Derivative of cosine is negative sine. We evaluate it at our argument xy, and now we need to multiply by the derivative of x times y. On the right-hand side, the derivative of 1, once just a constant, is going to be 0. And then we differentiate sine of y using the chain rule to give us cosine of y times dy dx. So we differentiated the outside function sine to give us cosine. We evaluated at the argument function y, so that's why we have cosine of y. And then we need to multiply by the derivative of that inside, which is dy dx. Okay, so let's take a moment and think about this derivative of x times y. From the way we say it, x times y, we recognize that this is a product, so we're going to use the product rule to do this derivative. So we have negative sine of xy. And now I'm going to write out what we're multiplying by. First, we're going to differentiate x, and we get 1. And we don't differentiate y. And then we're going to keep x undifferentiated and multiply by the derivative of y. Okay. And so this is equal to cosine of y dy dx. All right, and we are going to keep our eyes on the prize and think about what we are solving for. We are looking for our slope dy dx. Okay, so we have two options. So number one is we could just do algebra right away, solve for dy dx, get dy dx as a function. Option 2 says that we could evaluate this expression at the point 2, negative pi, 2 being our x value and negative pi being our y value. And this clears out a lot of the function notation so that it looks like a simpler algebra problem. So why don't we try that out here? So I'm going to say at 2 negative pi, what this is going to look like is going to be negative sine of negative 2 pi times negative pi plus 2 times dy dx is equal to cosine of negative pi times dy dx. All right, and let's think back. Sine of negative 2 pi is the same thing as sine of 2 pi, which is just equal to 0. Cosine of negative pi is just equal to negative 1. And so this amounts to 0 equals negative dy dx. So dy dx is 0. All right, and so our tangent line is going through the point 2 negative pi, and we have slope 0. And so it is just the equation y equals negative pi. We could also do this through the formula y minus negative pi equals 0 times x minus 2. The right-hand side gives us just zeros. And then, so y plus pi is 0, and y equals negative pi. But it's probably easier to just think, okay, we have slope 0, and I know that my y value here is negative pi, and so that is going to be the equation of this straight line. So when I said that the tangent line and the normal line have slopes multiplying by to negative 1, this is the one exception to that. When we have a tangent line that is horizontal, then the normal line will be perpendicular, so it's going to be vertical, so no slope is defined. Similarly, if the tangent line was vertical, the normal line is going to be horizontal. And so again, when you multiply them, it's not defined. Okay, so let's build our normal line though. So what we're saying is that our tangent line here is y equals negative pi. And we're going through this point to negative pi. Okay. What we want is something perpendicular. This is going to be our normal line. And we can see it has equation x equals 2. The x value is fixed throughout, and we need to go through the point to negative pi. And so we're looking at the point x equals 2. Let me bring this curve up on Desmos, and we can take a look. Okay, so this is our graph. Cosine of xy equals 1 plus sine of y, and I've put in a point to negative pi. So let's check our work. We're going to put in first the equation of the tangent line that we found, y equals negative pi, and we see this looks great. This looks a lot like our function here at 2 negative pi. And let's also put in the equation of our normal line, x equals 2. We see that it's perpendicular to our tangent line, and it goes through the point of interest. And so, even though the function that we're looking at is not at all, well, even though this implicitly defined curve is not at all a function, we're still able to talk about tangent lines at this point. Great.